Okay, so welcome back. We're today gonna sort of go back into the gym instructor, and particularly we're picking up just a little bit later than where we were. I want to start on the learning outcome 4, which is the section on joints. And what I want to do, I want to go through the lecture, as it were, fairly quickly. Because there's some of the work that you can do whilst I wait, and then increasingly I want more for you to do in your own time. So this lecture, I would suggest you consider it as being something that you use alongside reading the course book that I've emailed out previously. So hopefully some of the terminology and what have you is familiar to you. I'll try and sort of fill in the gaps as much as I can as we go along. So at the end of the session, really, I want you to be able to understand the joints that are found within the skeletal system. So we'll look at the sort of broad categories of joints, and then we'll sort of dig deeper into one of the groups of joint. So really, at the end of it, you should be able to describe each type of joint and start to get an appreciation of how the joint structure influences the movement that's capable at each of these joints. And we start to sort of just kind of piece together the terminology, and hopefully it might give you a little bit of insight into the way that joints move, also the way that joints get injured. I think it's quite useful to know. So this is a little bit about where we picked up last time. So this is the axial and the appendicular skeleton. So if we look at the axial skeleton on the left-hand side, you can see that sort of central core, if you like, is in blue. And we talked a little bit about why we classify it differently. And we saw that a lot of the axial skeleton was about protection, and a lot of the appendicular skeleton. So you can see there, the appendicular skeleton consists of the shoulder girdles and the arms and the hands that hang off it. And then we've got the pelvic girdle and the legs and the feet that hang off that. So we sort of described the appendicular skeleton as being a little bit more about movement, sort of walking, running, and also sort of grasping and reaching. So the appendicular skeleton and the axial skeletons are sort of broad classifications of the skeleton. Then we looked at different bone types, and we looked at the different classifications of bone. We sort of had our long, short, flat. We saw our sesamoid bones, etc. So, and our irregular ones as well. So we kind of dug into that a little bit as well. So today we're going to do a similar thing, but with the joints. So by the end of it, you'll be able to describe the classifications of joints, and I'm going to give you a little bit of time to complete that in your workbooks in session. You'll describe the structure of synovial joints, and that's another one I'm going to give you a bit of time in the session to do. We'll describe the types of synovial joint and their range of motion. So I may give you a little time just to sort of draw the outline of that in your workbooks. And then you're going to describe joint movement potential and joint actions, which is going to go through into another session. We'll also briefly consider the short and long-term effects of exercise on the skeletal system. So this first slide looks at the broad classification of joints. And you can see on the bottom there, we've got a skull. So when you're born, your head is made up of kind of well, as you're growing, as you're a fetus, your head is really made up of kind of plates of cartilage. So you've got these sort of blobs of cartilage, and then inside begins to ossify. So you start to form bone from inside, and gradually that sort of bony formation spreads out into these plates of bone. And if you look on that picture of the skull, you can start to see that a little bit. So you can see if you like, can you see just along here, there looks like a little joint, and then here you can see a little line, and there, and there, and there. So basically the bones will have started as cartilage, and from the inside to the out, that cartilage gradually ossifies, it becomes bone. So the same thing will have happened to this one, and the same as all the others. So by the time you're entering the world, the edges of those bones aren't quite fully ossified. They haven't quite fully turned into bone. There's still a bit of knitting together of those bones to go. So in your first year of life, gradually those cartilage plates join together to form joints. And that first type of joint is called a fibrous joint. So they're completely immovable. So your first type of joint we'll look at is a fibrous immovable joint. And there's another place you'll see them. Let me just grab my pelvis. There's a similar sort of thing with the pelvis as well. It's made up of, oh, this is harder than I thought actually. So we have a bone here called the ischium, and we have a bone here called the ilium. So the ischium and the ilium look together like they're just one bone, but they're actually made up of 3 bones, and those are all joined by a fibrous joint. We have cartilaginous joints. So again, if you stick with this is so here was my ischium, here's the pubis, and then in between it we've got a bit of cartilage called the pubic symphysis. You've also got at the bottom here an intervertebral joint, which also can be considered to be a cartilaginous joint. And then lastly, we've got these types of synovial joints. So we'll dig into those in much greater depth. The synovial joints are the ones that are much more freely movable. So really the joint that sort of will predominate in our appendicular skeleton and allow us to move and work freely. So those are going to be the focus of most of our work, but it's useful to just consider fibrous joints and cartilaginous joints, just so you can describe where they are and broadly how much movement you'd expect at them. So let's dig into the joints. Oh, I've still got my moving up here. So you can see on that right hand side picture, can you just see where those plates of the skull have fused together, and they're called sutures. So there's basically no movement at a suture, not when it's an adult skull. So the one on the left hand side shows that really nicely. So you can see this suture, this coronal suture down the middle, and you can see it's got a kind of a wiggly shape to it. It means those plates of bone are kind of knitted really firmly together. So immovable fibrous joints are where bones have joined, usually through cartilage or two points of cartilage just joining together and creating a fibrous junction between 2 bones. So we describe it as a joint, but really we don't really consider movement as happening. So here's a cartilaginous, slightly movable joint. So again, that pubic symphysis at the start, or that I showed earlier, that's this part here. So the pubic symphysis allows really, really minor motion at that pubis joint. So it's where 2 bones are separated by a disc of cartilage. So other cartilaginous joints, can anyone give me an idea of any other cartilaginous joints in the body? Anyone else? Cartilaginous joints? Well, we've got, I showed before, in our spine, we've got the intervertebral discs. So you can see that intervertebral disc there, right at the base of the spine, but we've got them obviously all the way up. We also have them next to our ribs. So as our ribs join into our sternum, so we've got a nice big flat sternum bone in the sternum bone here. And then when you take deep breaths, you might be able to just feel your rib cage rising. So the ribs obviously are bones, and they join into that sternum by a cartilaginous joint called your sternocostal joints. So the sternum and the ribs. So the sternum and the ribs have a very small cartilaginous joint that just allows minute movement, particularly on that forced in-breath. And then lastly, the most kind of important to us today, we've got these synovial joints. So the synovial joints are again where two bones are joined, but in the middle we have this very unique capsule that contains cartilage and synovial fluid. So I'm going to just talk you through this structure fairly quickly. So first of all, what I want to draw your attention to is it's always quite good to draw along these. So what I would suggest is grab yourself a pen and a piece of paper, and we'll draw ourselves a synovial joint. It's useful to go through the process. So grab yourself a pen. I'll do it on screen. It's a real test of my art with this little tracker pad. There we go. Here's bone 1. I'll do bone 2 in a different color. No, I won't. I'll do it in the same color. There we go. So I'll do it really close. Oh, maybe too close. Okay. That's a pretty bad picture so far. So that's a bone. There's two bones. Now, in your picture, the first thing to add is cartilage. So synovial joints are, one of the things that characterizes them is the presence of articular cartilage. So I would put yourself in some articular cartilage in a nice color like blue. Most anatomy texts, you'll see it's sort of blue or purple. And articular cartilage is really there because it's so slippery. Its structure is it's an interesting structure, but it's made of these little, I guess like collagen fibers, but they attract water, and so you've got a surface which is really slippery, almost like like ice or something. It's very sort of full of fluid, but really slippery, hard and slippery. So you've got those two bones joined end to end, but each end of the bone is covered in cartilage. So cartilage allows it to be slippery. Now, if cartilage is just left alone, it doesn't have nutrition. It will lose its fluid content, and it won't slide as nicely. So there's two things that make it possible to live. Now, first of all, we have what's called a synovial membrane. Now, I've drawn a bit of a wonky picture there, but the synovial membrane, and we have to imagine this in sort of 3D. So the synovial membrane, if you look on the picture on the right hand side, I'll just show it there. So what the synovial membrane does, remember that's going to go all the way around that joint, is the synovial membrane takes nutrients from the blood and it creates synovial fluid. So the synovial membrane is really kind of supported by a sort of a little capsule. So I'll sort of draw that in here. This picture's getting messier and messier. So the capsule sort of supports that joint. There we go. Terrible picture. So you've got that synovial membrane there supported by a capsule, and that synovial membrane allows the production of synovial fluid. So I'm going to just draw synovial fluid inside the joint now. So that synovial fluid there goes all inside that joint. So synovial fluid keeps the joint moistened and it allows the cartilage to slip. Over the top, you've got a great big ligament. So a big ligament here will support that joint and support the capsule. So kind of like that. So the important thing really to get across here is that structure on the right hand side of a synovial joint, it allows the joint to be very movable. It allows the two surfaces to articulate very smoothly, and the synovial membrane kind of maintains the health and the nourishment of that joint. Now, what you see also is that this joint is that one. It's just a finger joint. So if you can imagine that, this joint is there. So this joint allows fairly limited movement, but it's a synovial joint. It's the same structure as I've got in my elbow and I've got in my shoulder. The same component parts are there. So when we see a synovial joint, we always see this kind of structure that we've got on the right-hand side, but synovial joints can be quite wildly different in terms of their shape, but they always have the same component parts. They have cartilage to allow the two bones to slide past. They have a cavity, a synovial cavity, which contains synovial fluid. They have a synovial membrane. They have a capsule or a fibrous membrane over the top. And that's it. So I'm going to press on and go and talk about another couple of types of joint. And then I'm going to give you a little bit of time in a while to just talk about the broad joint characteristics or the broad types of joint. So let me just clear that off. So those are the parts. So what I've got here is a hip joint. So can you see the synovial cavity? So this is what's called a ball and socket joint. So if we think back to our classifications of joint, we've got our fibrous, we've got our cartilaginous, and now we've got our synovial joints. Our synovial joints, we break up into 6 different types. We'll look at those individually. This is a ball and socket joint. So what you can see is the bone at the bottom is the femur. So can you see how that femur goes into that ball type shape at the end? Now, if you look at that femur, can you see the cartilage on the end? I'll just sort of colour it in the same colour as I did previously. but we should see, can you see, whoop, the cartilage just on the end there, on that end space, just drawing it in a bit of a purple color. So that's the ball. Oh, that's a bit of a dodgy pick, wasn't it? So that's the ball of the ball and socket. So the cartilage is at the end of the joint, but also in the socket, you can also see there's articular cartilage. So you can see that, I'm just popping it in purple, over there. So that whole space, we've got the socket lined with cartilage, and we've got the ball lined with cartilage. So I've now asked, can you find the synovial cavity? And you should be able to find it because it's got a great big sign saying synovial cavity. And you can see inside, it's all colored yellow, just to designate that it's a space. But remember that space is filled with synovial fluid. So the synovial fluid allows the lubrication of that cartilage. Now, that doesn't come from nowhere. So what you can see is on the end, can you see these little areas here? Can you see that bit that's colored in red? That's our synovial membrane. So the membrane, remember, takes nutrients from the blood and creates this synovial fluid. It's kind of like a really thin, almost kind of oily fluid that allows those surfaces to be sort of maintain their sort of slipperiness and also their nutrition. So the key thing is to show that all synovial joints have common parts that we saw in the previous picture. But when we start breaking down our joints into different components or to different names, their shapes are very different. So before we dig too deep into the synovial joints, I'm going to ask you to go back. So I'm going to just clear that off. I'm going to clear this off. So what I'm going to do now, we're going to go back to, where should we go? Let's say this one. Okay, so I'm going to pause here and just get you to write into your manuals the first sort of answer, if you like. Well, actually, no, I'm not going to do the answer. I'm going to just get you to put in your headings. Okay, so all I want you to do is just create on your page 16 of your workbook headings for each of these classifications of joints. So I want you to make sure that you've got one that is fibrous immovable, one that's cartilaginous semi-movable, and one that's synovial freely movable. Okay, so just put in headings in your page 16. It says 4.1, describe the classifications of joints. So I just want you to write down your headings. Okay, I am going to carry on with the types of synovial joint. So hopefully you've got your headings down. So you're going to talk about, when we finish this, you're going to talk about the classifications of joints being fibrous, cartilaginous, and synovial. Then what you're going to do is for 4.2, you're going to describe essentially this slide. So you're going to describe the fact that you've got two bones that articulate. You're going to explain that the ends of those bones are covered in cartilage. You're going to explain that that cartilage is maintained as sort of slippy because of the synovial fluid inside that joint. And you're going to say that that synovial fluid comes from that synovial membrane. The synovial membrane is supported by a fibrous capsule and may be reinforced by that ligament. All the information that's on here. So I'll press on with the different types of joint, but that's going to be your job at the end of this session. Okay, so we're going to dig into the different types of synovial joints. So remember, we had our broad classification, fibrous, cartilaginous, synovial. Now we're taking those synovial joints, turning and looking at our 6 different types of synovial joint. So the first type of synovial joint is this ball and socket. So what you can see on a ball and socket, can anyone tell me 2 locations of ball and socket joints in the body? Tell me in the chat box 2 places where you've got ball and socket joints.
Sorry?
Anyone?
I can teach you better, Lydia.
I get distracted.
What's he saying?
Come on, we can get some... No? Okay. Okay, so, yeah, someone's coming in private. This is good, yeah. So we've got them in our shoulder. So our ball and socket in our shoulder and also in our hip. So again, this is my hip. So what you can see, so here's the pelvis.
I don't even know where
to
to
turn that around, you can see this great big hole here. So that's a ball. Oh, sorry, that's a socket for a ball and socket joint. So you can imagine the femur is sitting into there. So on that picture in the bottom right, what you can see is that ball-shaped femur fitting into that round socket. So this is really, if you see in that hip, the femur kind of fits almost, the socket's almost around it. We've got a cartilage called a labrum inside, which helps maintain that sort of tight fit in that joint. If you've ever seen people trying to perform a hip replacement, the big challenge is getting the old hip out, getting the old femur out. And it almost looks like kind of carpentry, the way they're just trying to sort of, you know, just sort of lever it out. It's a really tough job. So we've got a really deep ball and socket joint in our hip. We've also got one at our shoulder. But you hear people dislocate their shoulders quite a lot, don't you? And the key difference between these joints is that in the hip, the socket is very deep, and in the shoulder, the socket is very shallow. And this very shallow socket in the shoulder allows us this huge range of movement. It allows us to grasp and reach and throw and catch and whatever. So it means that we've got a very mobile joint, but perhaps it's become extra mobile at the sacrifice of a bit of stability. So we have ball and socket joints where we need movement in all planes. In our hip, we have a very deep socket. In our shoulder, it's relatively shallow. So here we've got a knee. So has anyone ever had damaged their cruciates, or anyone had any serious knee injuries? Anyone in the team? No. Okay. So the knee is a very pure hinge joint. So a classic hinge allows movement in one plane. So we call this, so in something like a let's say my elbow, for example, I've got my humerus and I've got my ulna. So where I have very pure movement, I'm narrowing the angle there. We call that flexion. In the other direction, we call that extension. So my humerus and my ulna are a very pure hinge joint. I'm allowed this movement because of the joint that my radius makes with my humerus. So my humerus and my ulna form a very pure hinge joint. When the joint is narrowed, we call that flexion. When it's extended, we call that extension. So a similar thing we have in our knee. So when we narrow, if I can get this up, here we are. May not work. Here we are. There we go. There's the knee. So when this joint is shortened, we call that flexion. In the opposite direction, we call that extension. Flexion, extension. So if you think about it, when I'm running, or if I'm jumping and landing, what I don't want is a wobbly knee that's got movement in all directions. A hinge joint allows me to absorb a lot of force and create a very stable joint to transmit that force through. So the knee has very strong ligaments supporting it and guiding the motion in that one direction, that flexion and extension. So we can see how disabling it is when those ligaments become broken or torn, because it means that the joint no longer has that support mechanism. So here we've got what's called a pivot joint. This one you have right at the top of your neck. So if you look on here, so I'm going to just colour very quickly. There we are. Now, where I'm colouring it in purple, this is called your atlas. So if you look at that bone, what you see is, I'll just pop it in a slightly different colour, is, can you see how where I draw it in orange, this is a kind of a round bone, okay? Now, on top of that atlas, where I've put those two little purple bits, your skull sits on top of that. So on top of that joint, your skull does this. So it just allows that slight gliding to nod and very slightly extend. Now, if you take that skull and pop it on that atlas, now can you see how that round bone is able to move around that little peg? So I'm going to put the peg in a nice red. Can you see that peg there? I'm just drawing it in. There we go. So that red peg is connected to the bone. So I'm just colouring in red down here. Okay, so that peg there fits up, and so that sort of round surface around is able to rotate. So the skull fits on top of that blue section, or the purple section, that allows that. And that, with the atlas on it, is able to rotate around that little red peg, and that is the pivot joint. So that pivot joint allows rotation at the top of the neck. That one's the really crucial one, that if that joint is torn, that peg hits your spinal cord and you'll die. So this is why when people have head injuries or serious neck injuries, you have to stabilize them absolutely, just in case. So the pivot joint is at the top of the neck. It allows rotation. We saw the hinge we have at the humerus and ulna and in the knee to create very pure flexion and extension. And we saw ball and socket joints at the shoulder and the hip to allow movement in all planes. So there are 3 joints. So let's crack on to the others. So now we've just got a couple more. This one's a useful one to find. If you just take your hand like this and just grasp your thumb and just try and move it around there. And what you'll feel is at the base. So if you feel your thumb, let's just get it like this. So here we have a very pure sort of flexion and extension. Here we have quite a pure flexion movement, but at the base, can you feel here, I can get movement in this direction, I can get movement in that direction, and so this gets quite a lot of movement across here. So I'm looking at this joint here, quite a lot that way, and then quite a lot as I wiggle it about. So I kind of get motion, a lot of motion in one direction, and then a lot of motion in another direction. So it's this joint here. Just have a little play with your own thumb. Give it a wiggle, try and let your hand go completely limp. And what you feel is you get, as I say, a lot of movement there and a lot of movement there. And it's allowed to do that by the structure being a bit like 2 saddles, two saddles or 2 saddle shapes that are joined together. So there's saddle 1, there's saddle 2, and that allows that movement in those 2 kind of planes. So we get quite a lot of movement, but it's still quite stable. So here we've got what's called a gliding or plane joint. There's a couple of examples of these actually. This one is at what's called the acromioclavicular joint. You see on there. Now, in our shoulder, we have our ball and socket joint. Okay, that's our big mover. So when I bring my arm up, this is called abduction, abduction. When I come down, it's called adduction, adduction. When I bring it out in front, we call that flexion. And as I bring it down behind me, we call that extension. So abduction, adduction, flexion, extension. Now, if you feel this sort of bony tip of your shoulder, we call this the acromion. This is called the acromion process. Now, if you look on that picture, it's actually a bit of your scapula. Now, if you feel your shoulder blade, your collarbone, you can feel where it connects to the sternum, and then you can feel it all the way along until it attaches onto that acromion. So the clavicle or your collarbone attaches on to your scapula at the acromion. What it does there is it moves just ever so slightly. There's hardly any movement. It's very well supported by ligaments, so that when the scapula is drawn up, so as I move my humerus up, the scapula kind of comes with it. As the collarbone, the clavicle elevates, there's just minute movement between the 2. So it's almost like you've got 2 flat surfaces which just allow the tiniest bit of gliding, just the tiniest bit of gliding. We've got similar joints in our feet, particularly around the tarsals, so where we've got those short bones that are joined together. When we land, when we put large amounts of force through our feet, they're allowed to just glide ever so slightly, just tiny little gliding movements, usually very supported by ligaments. So you probably would really struggle to feel the movement, just tiny bits of gliding. And here we've got our ellipsoid joints. So here we've got one shape, like it's a difficult one actually, these. If you feel your finger, it really just does allow a sort of hinge joint. It acts like a hinge really. But if you took all the ligaments away, you'd allow a tiny little bit of rotation. There'd be a little bit of side to side movement. An ellipsoid joint usually has one bit where it's almost like a ball, but it doesn't fit into a socket in the same way that a ball and socket joint would. The bone it goes up against, particularly in your fingers, is usually a little bit flatter. So we call them ellipsoid joints. We sometimes call them condyloid joints. They're sort of not, they're quite difficult to define actually. But what you can see in that picture of the finger on the bottom right, can you just see, I'll just sort of double annotate it there. So where you look inside, where I've just put that line, if we imagine that bone is actually quite rounded, and it means that other little bone there almost glides underneath it. So it slides around that sort of rounded ball shape. So the ellipsoid joint we find between our fingers, or between our phalanges, and it allows that one bone to almost kind of glide round. So here we've got we can get a lot of movement out of that finger because it's gliding around it. Okay, so one side has a ball shape and the other, it's not quite a socket, but it allows it to slide around. Couple of things on chat. Let me just see. Yes, Ash, it is going on the channel. Don't worry. Okay. So here's just that picture again. Remember, what I was trying to get across was the way that one bit is a ball. So can you just see, I'm just going to draw that in. Can you see that bit of the finger where I've just sort of linked it to? Can you see how it's sort of a rounded shape at the end? And it's kind of fitting into not quite a socket on the other side. And what's different about these and ball and socket joints is ball and socket joints allow rotation. They allow movement. So if this is my ball and socket joint, I'm able to do all these kind of rotatory movements. But in my finger, I can't because of the ligaments that are connecting the fingers. So we've got these really strong ligaments on the front and the back, which prevent that rotation. Whereas in our ball and socket joints, we have loads of rotation. So that's the lot. Ball and socket, hinge, pivot, remember in the neck. We've got our saddle joints. Remember though, allowing base of the thumb, a lot of movement in one direction, a lot of movement in one other, but no kind of combined rotation. We had our plane joints. Remember, really minute movements between the collarbone and the scapula, that acromioclavicular joint. We also have them in the feet between the short bones. And then lastly, we looked at that ellipsoid, that sort of quite strange structure where you've got one kind of really rounded surface fitting onto another, similar to a ball and socket, but just not allowing that same level of rotation. So here's the quiz. So what I'm going to get you to do, so on the right hand side, we've got a load of joints, or we've got the big six. And on the left hand side, we've got a description. So what I want you to do in chat box, I want you to pop in your answer. So fastest fingers, who can give me that? So number one, just put A, B, C, D, E, or F. So let's go. Okay, counting down. Anyone? Anyone? Found at the base of the thumb, between the carpals and metacarpals. So can you remember it was those, what I was saying about those two joint directions? We have, who's given it? B, well done, good stuff. Okay. So next up, it's taking its time. So found at the top of the neck, permits only rotation. Anyone? Found at the top of the neck, permits only rotation. That's it. So that was a pivot. So next up, the rounded end of a bone, sometimes known as the condyle, articulates with another bone. It's not a ball and socket. They don't allow rotation. So which of those is it going to be? So the rounded end of a bone articulates with another bone. It's not a ball and socket. So that was the ellipsoid or condyloid. Next up, a ball-shaped bone fits into a round socket, allows movement in all directions. Should be an easy one. Anyone? Where's it going to go? So a ball and socket. Allows only movement in one direction, e.g. flexion and extension. What have we got? What have we got? So we see that in our hinge. And then we're now going to go to the final one. Oh, cleared it all. Can be found, these joints allow a small sliding movement. They can be found in the feet, in the tarsals, and shoulder joint at the AC joint. So it was the only one that was left. So that's your gliding joints. Okay, so that's the key synovial joints we'll need to cover. I'll direct you to working with your workbook on these. And at the end of the session, I'm going to ask you to fill your workbook out. Okay, so we're going to this very quickly, and then we'll grab a brief break. So the effects of exercise on the skeletal system. In the short term, we can consider it to be to increase the synovial fluid production. So remember that synovial membrane was where the synovial fluid was produced. And when we exercise, when we start warming up, our body starts creating a little bit more synovial fluid. And importantly, it starts coating the joint with it. So it means it's nicely lubricated. It's going to optimize the range of movement. Long term, in terms of what happens with long-term exercise, it's mostly positive. So ligaments around joints become stronger unless you put them through extreme ranges of motion all the time. So sometimes people like, throwers, their ligaments become slightly stretched. But generally, if we put appropriate load through ligaments by weight bearing, with weights, the ligaments will adapt by becoming stronger. So you may get slightly more collagen fibers. They might become slightly thicker. And importantly, and this is a really important benefit of all types of weight-bearing exercise, is that it actually stimulates our body to lay down more bone mineral. So this means that they are stronger, and it means they maintain their strength for longer. So our bone mineral density peaks in our sort of 20s, and from that point we never get more. You know, we're always sort of, our body's always building bone and breaking it down. So it's a constant balance. We absolutely optimize it when we're relatively young. Over time, our ability to lay down bone begins to decrease. So for some people, if they haven't optimized their bone mineral density, it means they're a greater likelihood of fractures and suffering from a condition called osteoporosis, where the bone becomes demineralized and almost looks like it's got little holes in it. So weight-bearing exercise is really important to promote, and weight-bearing and weightlifting exercise has a really positive association with bone health. So really, we've gone through it in a fair pace, but I think we've covered enough for you to then go back to your books at the end of this session and fill this in. So we described the classifications of joints. So remember, the broad classification of joints are fibrous, cartilaginous, and synovial. We looked at the structure of synovial joints. So particularly, we considered the importance of cartilage on the ends, of the synovial membrane, of synovial fluid, and that supporting capsule. We considered all the different types of synovial joint. So there's 6 types of synovial joint, and we went through each one to just describe their basic structure and consider the range of movement that structure allows. So we briefly described joint movement potential. We didn't go into full depth, but we had a little touch on it. And then lastly, we just briefly considered the short and the long-term effects of exercise on the skeletal system. So I'm going to break there. What I'm going to do, I'm actually going to stop the presentation and end the meeting. I'm then going to get you back in 15 minutes time. So you'll need to rejoin the same meeting because it allows me to record and I can upload that later on. So if there's no further questions, I'll do that now. And then I'll get you to come back in. If we start the next part at 15:15, that would be brilliant. Okay, I'll see you in 15 minutes.